Okay. So quiet, please. Like I say, it's not going to take that long. I think you want to watch the movie. Even got some snacks and drinks. Okay. The remember what I mean. Just remember the whole concept of exponents. We've dealt with exponents already, but if I say something is raised to a power, if I say, let me get a blank file. 2 to the third power, what does it mean? When you raise it to that exponent, it means that it's 2, that's not going to work. Okay, quiet, please. Okay, it means 2 times 2 times 2, right? Whatever is that exponent is telling you how many times that number is a factor. Okay, when we start getting into variables, right, it's the same thing, right? Say x to the third, that's x times x times x. So the properties of exponents are how do we deal with exponents, because we're going to get them in a lot of different combinations that we have to know how do we simplify. And this is a part of Algebra 1, and it comes up in Algebra 2 and later, and we generally don't do very well with it at all. So the first couple properties that we learn are called zero and negative exponents, right? The first property being anything to the 0 power equals the number 1, right? It doesn't equal that thing to the first power, it's the number 1. 4 to the 0, 1. Negative 3 to the 0, 1. 5.14 to the 0, 1. I always think my refrigerator to the 0 power is 1. Anything to the 0 power is 1. When you see it, right, you can just cancel it out, replace it with a 1, or most of the time just cancel it out because we don't usually write the 1 anyways. So anything to the 0 power is 1. Right? Negative exponents, like this one, 7 to the negative 3. If it's 7 to the negative 3 in the numerator, then you can flip it to the denominator, it becomes a positive 3. Right? So that's the way you resolve negative exponents. Negative 5 to the negative 2 means 1 over negative 5 to the positive 2. Now, one thing that they didn't show in their example here, it could work the other way too. It could be that you get this, let's say I've got 1 over 4 to the negative 2 in the denominator. Then to simplify, you're going to flip it, again, to the other side of the fraction so that it's positive. And most of the time when they say to simplify, they mean don't have any negative exponents. If you had negative exponents, do something to get rid of the negative. That would be part of it. So looking at these here, right? 4 to the negative 3, if I applied this property right here, you would say is get rid of the negative by doing what? 1 over 4 to the positive 3. Negative 5 to the 0 is this property? 1, right? 3 to the negative 2 is 1 over 3 to the positive 2. 6 to the negative 1, 1 over 6, right? Negative 4 to the negative 2. Well, yeah. Now, you can also simplify those. Like 1 over 4 to the third is 1 over 64. 1 over 3 squared is 1 over 9. 1 over negative 4 squared is 1 over 16. Right, so negative and 0 as exponents. How about letter A, x to the negative 9th? Now we got variables. 1 over x to the 9th. Okay, 1 over n to the negative 3. Okay, now the negative exponent is in the denominator. How do you resolve it? Say again, more? You flip it to the numerator. That's n to the positive 3 in the numerator, right? Don't have to write the over 1. How about this one's got 3 different things in there, right? What is the negative 3 telling you to do? It's just on the C, right? It doesn't affect those factors which are not raised to the negative 3. So don't flip anything else. It's 4b in the numerator, c to the third in the denominator, right? How about the 2 over a to the negative 3 becomes 2a to the positive 3, okay? And how about this one? If we're going to get rid of the negative exponent, we've got to move one of them, right? But not both. What'll it look like once I've n to the 5th, m squared, right? Move only the one that had a negative exponent. Okay. Easy? Should be easy. Okay, the next thing is multiplying, right? If you're multiplying two factors that have the same base, in their example here, it says a to the m, a to the n, but generally what it means is it's the same number being raised to different powers. 4 to the 3rd times 4 to the 5th. Then how do you simplify? You add the exponents. That's 4 to the 3 plus 5, 4 to the 8th. Right? B to the 7th times b to the negative 4th. Add the exponents. 7 plus negative 4 is 3. How about 8 to the 3rd times 8 to the 6th? How many 8s would that be? It would be 3 plus 6, which is 8 to the 9th, right? I mean, again, 8 to the 3rd means 8 times 8 times 8. 8 to the 6th is 8 times 8 times 8, 8 times 8 times 8. Now, how many do you have? You have a total of 9. 6 from here, 3 from here, 8 to the 9th. Okay, let's see. 0.5 to the negative 3rd times 0.5 to the negative 8. In terms of the exponent, multiplying, what would I say? That would be 0.5 to the what power? .5, add the exponents. Negative 3 plus negative 8, negative 11. Okay, now get rid of the negative by what we did on the last slide. How do you resolve the negative exponent? Flip it to the denominator, right? So this is 1 over 0.5 to the positive 11. Okay, now here we have 3 factors. All have a base of 9. 9, 9, 9. So add up all the exponents. How many 9s total does that make? See, negative 3 plus 2 is negative 1. Negative 1 plus 6 is 5. Okay? So now variables. Variables here, okay? So I've got x to the 4th, x to the 9th, and x to the, what power is that? It's a 1. Okay, so how many x's do I have?
Pardon me, Mr. Callahan.
Yes.
Can you please send Taylor Hassel to the dean?
He's not here.
Thank you.
Okay. How many x's total is that? 4 plus 9 plus 1, 14, right? And now what are you going to do with the 5 times 3? Multiply them together, 15. Okay, how about this one? Which are the two that we can add exponents on? These two have the same base, right? We can't do it with a d, not the same base. Okay, so how many c's are there? C to the 3rd times c to the negative 2 should be c to the 3 plus negative 2, which is 1. So it's just c to the 1st. And you still got your d squared. Okay, now what are you going to do with the negative 4 times 7 times 2. Multiplying. What is negative 4 times 7 times 2? Negative 56. Okay, how about this one? Which two can we combine? The j squared times j makes how many j's as the factor? 3, right? And the k to the negative 2 is still there. And there's a 12, that's still there. Now, last step, how do you get rid of the negative 2 as an exponent on k? Flip it, right? 12 j to the third over k squared. Right? So, one more property, I believe. No, I left it right there. So the homework is going to be page 195, 1 through 6, 203, 1 through 6. Plus, I'm going to give you a worksheet, which I would have had us doing right now. But I'll just say you could either work on it while you're watching a movie, or you can take it home and turn it in next class. Okay? That is the